Still moving forward. Here we go, folks. The next question is the AP 2018, number 4. I think they're going to use parts of this. I see a graph. I'm most likely going to be asked about derivatives of the graph or integrals of the graph. And you always have to take into account what they're actually asking you for and the things you're looking for. You're either going to be looking at values, derivatives, or concavity of particular graphs. I know I have the problem here. I've rewritten it up over here so we can see it. I'm going to focus a little better. Hold on. Hit the focus. Make sure you have your packet out in front of you so you can mark up your graph as we go. Okay, the very first question says, so they give me a bunch of information. I'm going to paraphrase the information for you. They said this is the graph G. It's a continuous function. And graph G is the derivative of the function f. That means that G equals the derivative of f. Okay, so that means that G is equal to f prime of x. That's what we're looking at right there. And it's a piecewise linear function, which makes sense as little pieces of lines right here. We can easily see the slopes up until 3. And then we have the function that makes up the rest of it, which looks like a part of a parabola coming along the way. Okay, so the first question is, they say that f of 1 is 3. What is the value of f of negative 5? So most likely, whenever they're asking about values of a graph, and I have a graph listed right here, I'm going to figure out how to find them. I'm probably going to be either taking the derivative or I'm going to be taking the integral. Okay. Well, here's what I know. I know that G equals the derivative of f. If I integrate both sides, that means that the integral of G is equal to f. So the values of f come from the integral of G. So here's what I know. They gave me 2 numbers to work with. The area under the curve from, they gave me 1 and 5. 1 to I'll do negative 5 to 1 of G of x dx equals, so the integral of G of x is f, equals f of x from negative 5 to 1. I'm going to slide this over a little bit for a second, which equals f of 1 minus f of negative 5. Basic rule on integrals, upper minus lower. So first of all, I can look at this graph, and anytime they give us a point and a graph, we're most likely going to be finding the area under the curve and then figuring out how it relates to the integral. So if I were to look at this graph, they told me that f1 is 3. They want me to find this, and I can find the area under the curve between between 1 and 5. Negative 5 will be all this area, all the way up to 1. Must be that much right there. So what I'm going to do is I'm going to compute those little areas out for us. Okay, just so we didn't have to watch me counting boxes, to find the area under the graph between negative 1 and 5, I broke it up into little regions. I just figured it out. This is a square, so the area is negative 9. Here's a little triangle. 1/2 base times height is negative 3 over 2. Here's a little triangle. 1/2 base times height gives me 1. So the area under the curve is going to be negative 9, negative 1, negative 3 over 2, and positive 1. So it's going to be negative 9 plus 1, negative 9 minus 1/2, which is negative 19 over 2. So this tells me what the area under the curve is. This gives me one exact value. And then to find the other one, this was a non-calculator problem, so you wouldn't have to work it out more than this. So negative, right over here, so we have it, negative 19 over 2 equals 3 minus, we'll call it v for the value we're looking for. To get v by itself, I'm going to add v to both sides. Subtract 19 over 2 from both sides. Add 19 over 2 from both sides. So v equals 3 plus 19 over 2. You could leave it like that. If you put it in the calculator, you would end up with 12.5. So this can be a classic one where they give you they talk about an integral. You got to find the integral as well as the area under the curve. Okay, next part. It says evaluate the integral from 1 to 6 of g of x dx. Okay, so basically we're going to find the area under the curve. From 1 to 6 of g of x dx. So if we were to look at this graph, we've already found a lot of the areas to begin with. There's 1. Let's do this other region. This region is another 4. 2 times 2 is 4. So if I add those regions up I have right now, I've got -9 minus 1.5 plus 1 plus 4. Put all those together and I end up with negative . I just double checked to make sure what I was doing here. They want the integral from 1 to 6. I even wrote it down right, 1 to 6, which means I'm starting right here. So that means I've got this unit right here from 1 to 3, which is 2 times 2. Okay, so I've got the integral from 1 to 3. And the integral from 1 to 3 is equal to 4. That's this piece right here. Now the area under curve for this one, if you take a look, there's a bunch of ways you can do it. If I'm going up to 6, I can put this right into my calculator. I can go integral. Let's put in the calculator, hold on. Okay, here we go. Menu, calculus, integral. Starting at 3, going to 6 of the function 2 parentheses x minus 4 close parentheses squared dx. And I got 6. So the area in blue right here is 6. So I'm going to add those two together. Let's put the light back on. The integral from 1 to 6 is equal to the integral from 1 to 3, which is 4, plus the integral from 4 to 6, which is 6. And I get an answer of 10 for that problem right there. Okay, part C on this one has a lot of tricky things going on. Let's see what we can see. They want to know where f is increasing. That means where f prime is positive. And they want to know where it's concave up. That's where f double prime is also positive. Okay, so the question is what things are we seeing? So that's what I want to kind of keep track of on here. That's the hard part on this problem. I have a couple of functions. I'm going to write some things down that usually help me out when I'm doing this. F prime, and f double prime are the things I'm looking at. The graph I have is G, and G is equal to f prime of x. So f prime is G. That means that f double prime is G prime. And f, we're not necessarily going to need to look at. So here's where it's so tricky, because we're jumping from function to function. The values of G are equal to the slopes of f prime, and the slopes of G prime are equal to the values of f double prime. So what I'm going to do is I'm going to create a couple number line graphs. I'm going to bring my graph back on here for a minute. And I'm going to create my number line graphs. F prime and f double prime and f. And I'm going to include some extra information here. This is G, this is G prime. So to figure out where f prime is positive or negative, at first I got to find where f prime is 0 or undefined. So where is G 0 or undefined? Well, G is 0 at -1 all the way to 0. G is 0 again at 4. So that tells me f prime. Now where I want to know that whether G is positive or negative. So before 0g is negative. From 0 to 4g is positive. And from 4 up, g is positive. So that tells me things about f. That tells me that f is decreasing, increasing, increasing. Okay, so now let's find out where f double prime is 0 or undefined. That will occur where g prime is 0 or undefined. That's the slope of the graph. So the slope of this graph is undefined at -2 because there's a cusp. It's 0 all the way between it's undefined at -2. It is undefined at -1. The slope is 0 all the way to 1. The slope is then undefined at 1. The slope is undefined at 3. And the slope is 0 at 4. In between, let's check for positive and negative nature of the slopes. The slope before -2 is 0. The slope between -2 and 1 is positive. The slope between 1 and 3 oh, I need a 2 on there too, don't I? Consulted with my question experts, and they had a much easier way of doing this problem. I like their approach better, so let's go with it right there. So they basically are asking me when the graph of f is increasing and concave up. So that would mean when is f prime positive, and when is f double prime positive. Well, f prime is g, is the graph of g, which is what we're looking at there. F double prime is g prime. We would need to know when g is positive and g prime is positive. So is there anywhere on the graph where the value is positive and the slope is positive? Let's look at the graph, see if we can find this where the value is positive and the slope is positive. Well, between 0 and 1, the value is positive and the slope is positive. And between 4 and 6, the value is positive and the slope is positive. So those are our two regions. So I'm going to rewrite the answer I had there. I did too much work on here. I agree with you. So where is it increasing and concave up? It's between 0 and 1 and 4 and 6. And what's the reason? Because f prime is positive and f double prime is positive. You can add the extra information about f prime is positive equals g prime. That does not have to be in there to solve that problem on out. It could be just that info. Thank you for the tip on making that problem a little bit quicker. Okay, let's take a look at the last part. Okay, so the last part wants to find where any poise are. So points of inflection for f would be anywhere where f double prime changes from positive to negative or negative to positive. And f double prime on that picture is represented by g prime. So is there anywhere on the graph where the slope changes, from positive to negative or negative to positive? So I'm going to look around. Find where the slope changes from positive to negative and negative to positive. So here's the slope that goes from 0 to positive to 0 to positive. The slope is 0 to negative to positive. The only place where the slope changed from negative to positive was at 4. So if they asked me to write down what those were, those poise, there's a poi at x equals 4 because f double prime changes from negative to positive. You can put more information in on there, but everything about points of inflection and changing directions is just about changes in first derivatives or second derivatives, change from positive to negative or negative to positive. Okay, there's our next question done. We'll send it on out. I shall see you guys next one in a little bit. Bye-bye.